Hello guys, this is Trockers. Welcome back. Okay, we have a problem on integration, and this problem is summarizing a lot of things. I can see we have completing the square. We are also going to apply some coordinate geometry. There is graph sketching as well as application of integration to calculating areas and volumes. So it's a lot. Okay, on the first part, we are supposed to express this expression 12x minus 4x squared into that. And on the second part, we need to find the equation of the tangent to the curve at that particular point. Then on part 3, we are supposed to make a sketch for the given information. Then lastly, we need to find the exact volume when r is rotated through 60 about the x-axis. Okay, so with that being said, now guys, let's quickly go over this. Okay, so we are given that we need to express item 1, we need to express 12x minus 4x squared in the form c minus ax plus b squared. So quickly, we can expand the left side. So it's c minus, here it's a squared x squared plus 2ab x plus b squared, which is equal to c minus a squared x squared minus 2ab x minus b squared, right? Which is the same as saying c minus b squared, right? Minus 2ab x minus a squared x squared. So now we can compare, right? So now we can compare. So we want to compare coefficients of x squared. So when comparing coefficients of x squared here, they're seeing that a squared equal to 4. So a is root of 4, which is just 2, right? Then we can compare linear terms. So when you compare linear terms there, negative 2ab equal to 12. Since a is 2, so negative 4b is equal to 12. So b equal to negative 3. Then we can compare independent terms. So if we compare these constants, is equal to 0, but my b is what? My b is negative 3 squared, which is 9. So our c is 9. So therefore, 12x minus 4x squared is identical to 9 minus 2x minus 3 squared. So we are done with the first part, right? Now, let's move on to the second part, right? So as you can see, second part of the problem, guys, we want to find the equation of the tangent to the curve y equal to 12x minus 4x squared at the point where y is equal to 8 and x is less than 3 over 2. Okay, so first, we are given this as y equal to 12x minus 4x squared. So when y is 8, we need to find the value of 8. But remember, we are given the condition that x should be less than 3 over 2. So 8 equal to 12x minus 4x squared, right? Here, we can just say 4x squared minus 12x plus 8 equal to 0. If I divide this, x squared minus 3x plus 2 equal to 0. Factors of 2 that sum to negative 3 are x minus 2, x minus 1. So when we solve, x is equal to 1 or 2, since x is less than 3 over 2, therefore x equal to 1. So we need this value, hence we have a point, 1 for x and 8 for y. Now, let's find our dy dx since we are talking about the tangent. So my dy dx, if I differentiate this, I'll get 12 minus 8x. Then when I find dy dx at x equal to 1, it's 12 minus 8 by 1, which is just 4. So now to find the equation, y minus 8 over x minus 1 should equal to 4. Y minus 8 is 4x minus 4. So y is equal to 4x plus 4. So the equation of the tangent to the curve at the point 18 is y equal to 4x plus 8. Right. So now we are moving on to part 3 of this problem. So when moving on to part 3 of this problem, okay, we need this question again. It's saying a finite region R is bounded by the y-axis, the tangent calculated in 2, and the curve y equal to 12x minus 4x squared. Illustrate by shading the region R on a sketch graph. Right. So guys, this is what we are given. We are given our equation is 12x minus 4x squared. When I factor this out, I'll get 4x, which is 3 minus x. Then x is 0 or x is what? X is 3. Obviously, when x is 0, y is 0, it passes through the origin. So this is the graph that we need. Right, we are looking for this graph here. Right, so we have 0 and we have 3. Right, so remember we once expressed this in that form. We don't need to complete the square here. It's already done because we expressed that in vertex form. So c minus, it was 9 minus 2x minus 3 squared. So in order for us to find the vertex, the coefficient of x here must be 1, so we can take out the 2. So you can just say it's 9 minus, so when taking out the 2 squared here, right, 2 squared is x minus 3 over 2, right, squared. So here it's the same as saying negative 4 x minus 3 over 2 squared plus 9. So my vertex here is 3 over 2, 9, right? This is my vertex. And the negative tells us that it has a maximum point and the curve opens down, right? So here it closes. So what we're going to do is 0.5 is half of this, right? So somewhere here, okay? So I'll just go ahead and make a sketch, right? I'll just go ahead and make a sketch. So this is my 9x minus this. Then we also have a tangent, guys. Remember our tangent, it's when x is 1, right? Remember the tangent just touches probably at 2 points, 1 at the bottom, whatever, but we want when x is what? 1 somewhere there, right? So we have a tangent, it must pass through this as well, right? When x, so y equal to, it was 4x plus 4. When x is 0, y is 4, right? When y is 0, x is negative 1. Okay, so it's somewhere here. I want my tangent to be like this, to be like that. Okay, something of this sort. We know that this is 4 and that is negative 1, right? That's my line y equal to 4x plus 4. So a finite region R is bounded by the y-axis, the tangent calculated in 2, right? We have it, and the curve illustrated by shading the region R on a sketch. So this is the region that we want here, which is bounded by the y-axis here, the tangent, and the curve, right? So that is the particular region we are looking for, right? So now let's move on to the last part of the question, which is question 4, part 4. Calculate in terms of pi the exact volume when R is rotated through 360 degrees about the x-axis, right? We are solving this problem here, the last part. We want to calculate in terms of pi the exact volume when R is rotated through 360 degrees about the x-axis, right? So one thing that we need, okay, allow me to get rid, okay, so here we are going to need this part here when x is 1. These are the conditions that I'm going to use. So I've got 0 and 1. So those are the conditions that I need, right? Remember, my curve here is 12x minus 4x squared, right? So whenever we calculate volume about the x-axis is equal to pi integral from x1 to x2 of y squared, right? But now, since there are two curves, when you do that for this upper part here, it's gonna calculate the area, the volume for, or area for this whole thing here. If it was area, it was going to be for the whole thing, then you subtract the one that is at the bottom. But since it's volume, we are going to rotate about the x-axis so that we have something of that sort. We have, if it's rotated here, it will be something of that, okay, because it's being rotated about the x-axis, so it's something of this sort. So that's the solid we are trying to look for here. Okay, so what we need to do is to say my volume here is equal to pi, then it's integral from 0 to 1 of the one that is at the top here. It's 4x plus 4 squared, subtracting 0 from 1. I'm going to subtract this 12x minus 4x squared with respect to what? With respect to x. So allow me to say it's integral from 0 to 1 of 4x squared. Here you can just say, if you want, I know you can use this one here, like f of x to the integral of f of x to the n is the same as f of x to the n plus 1 over n plus 1 times the derivative. It's still okay, but allow me just to do it this way. If I expand that, it's 16x squared plus 2 times 4, 4 times 4. That's 16 times 2 plus 32x plus 16, right? 2 times 4 times 4 times 4, 16 times 32. Okay, with respect to x minus integral from 0 to 1, we are going to integrate this. That squared, 12 squared is 144x squared, right? 144x squared minus 2 times 12, 2 times 12 times 4, right? 96x cubed plus last term squared here. So we want to differentiate this, right? Okay, so when we differentiate, we want to integrate. So when we integrate here, we are going to get 16x cubed over 3 plus 32x squared over 2 plus 16x, right? Okay, 0, 1 minus 144x cubed over 3 minus 96x to the 4 over 4 plus 16x to the 5 over 5. My limits are 0 and 1. Let me not forget the pi here. Let me not forget the pi. We have our pi, which is equal to, I'm going to keep the pi. Okay, let me just put the 1 first for this one. For this one, let me summarize here, right, so that I don't waste time. So if I put 1 there, it's going to be 16 over 3 plus 32 over 2, which is 16, right, plus 16, right? This simplifies to 112 over 3 minus, if I plug in 0 here, since all terms have x is just 0, then subtracting, I'll do the same here, 144 over 3 minus 96 over 4 plus 16 over 5, minus 96 over 4 plus 16 over 5, which is 136 over 5 minus 0, right? And here, these are now units cubed. All right, so here, when I say 112 over 3, subtracting 136 over 5, I'm getting 152 over 15 pi cubic units, right? Cubic units. So guys, we are done. This is how we find the volume. So what is important is to pay attention to the limits and also to your integration as well, right? With that being said, guys, I have to sign out. I will see you in the next segment. Take care.